Hello everyone, today I am going to deliver a lecture on deflection calculation by virtual work method or unit load method for frame. So, there is a first of all I will try to cover the theory of virtual work method or unit load method for frame. Then I will give the some example of virtual work method or unit load method for frame. So first of all, I am just covering this virtual work method. This is the determinate structure. We can analyze this. When we see the indeterminate structure, then we have to go to the force method or moment distribution method or stiffness method. That's why I am applying virtual work method or unit load method. Okay, let's see the theory. Here is the first theory we can see here. So there is no new theory as it is we have been seen here in beam slab. So in this case we have been seen the deflection theta equal to integration of m1 m naught and ei. So m1 and m1 and m eta. M1 is coming from we can say it's a real frame, and m naught is coming from the virtual frame. So let's see the example. So we can see an example to determine the horizontal displacement at point C. So we have to calculate the horizontal displacement at point C. The figure is shown here, the frame structure. The point C is given here. So this is the case we have been seeing the real frame, and another one is the virtual frame. So at first I will see the real frame is here. So we can take the two portion. This is the x1 and another one is x2. So x1 we have been taking here for taking the moment is here. So as we have, at first we are at first we are calculating the moment here. So if you take the moment is m1 is here. So 4 into 10 into 5. So you can see here the 4 and 10 is the total length, and 5 is the distance. 10 divided by 2, which is 5, and RC equal to 8. As you can see, the RC is here and 8 is the perpendicular distance, and in this case we have found RC equal to 25 feet and upward. So we can see here RC is here. And Ry will be the equilibrium condition. As Rc is upward, then Ry will be downward. So and f of Rax, we will calculate the Rox. In this case it will be known here 4 into 10, which is 40. 40 keep is going to the left to right. That's why the another Rox is going to the right to left. Okay, so now we're going to the solve this problem. As we know, as it could be calculated for the deflection point C. So we have to calculate, we have to use, we can consider this frame is a determinate structure. That's why we will use the virtual work method, or we can say unit load method. So in the load method we can use the real frame is here, and another is virtual. Virtual is one unit load is applied where it is asked the horizontal displacement at C. That's why we will use this here. Okay, so this is the x1 and this is the x2. X1 as we if we take the moment is here. So what will be happen? M1 into 40 is given here. 40 into x1 is the distance is here, as we know the distance is here, and minus 4 into x2 x1 minus 4 into 4 is unit load into x1 into distance, and x2 divided by 2 is a as a UDL load. That's why it is acting on the middle of the portion, and in this way we will getting the M1. So what will be x2? This is the x2 from the support of C1. So you can see this is the portion of x2. I'm just taking here x2. X2, there is a load 40 feet. If we take the moment is here, so if we take the moment is here, so it will be MC 25 into x2. X2 is here, so MC equal to 25x2. Okay, so two equation is finding from real frame analysis. I am just covering here. So this is the small sorry, this is the capital M. Now we can see the real virtual virtual frame. Now we can consider a small m. Okay, so as we know, this is the m1. So what will be rx1, as we have been applied a one keep in left to right, as in question is asking displacement point C horizontally. So that's why we have been applied x1. So for the perpendicular, so the equilibrium condition, if we go to the left to right, then it will be right to left. Okay, so what will be value of RC? RC is nothing but we are taking the moment of MA is here. So 1 is here, and distances, as we know, that 10 feet. So 1 into 10, RC into R, RC into 8 will be this distance is 8. So in this case, RC we have been found 1.25. So 1.25 is upward. For the balance purposes or equilibrium purposes, it will be downward. Okay. So now we can see here x1. We can take the moment x1 is here. So if we cutting here, so moment will be m1 into 1 into x into 0. So m1 equal to minus x. So in this case, we are taking the similarly x2 is here. So we can taking the x2 is here. One keep is going to the here, and 1.25 is upward. So m into 1.25 into x2, and this equation will be found. So now we can see here is the equation we have been found from virtual frame, which is small 1 and small 2, and we have been found the real frame, which is block letter or big letter of M1 and a big letter of M2. Now we are just calculating del C in horizontal, which is M1, which is real frame, and small l is virtual m. So let's see, we are taking a limit 1 to 10, as we seen here. The 10 is a length, and this is the vertical portion 10, and the horizontal portion is another 2, which is x2. Okay, so we can see minus 40 into x1. This is the equation, minus 40 into x1 into x square, and minus x is taking from the virtual frame, as we have been seeing. This is the virtual frame, m into m1. So it will be bigger m into m1. So we can see we can say this is the m, and this is the m1, and this is the another portion for x2. We can see here the limit will be 1 to 8. Why? Because the x2 is taken this portion, or this portion length is 8, and m2 have been found 25 into, it will be 1.25x. So in this case, 25 into 1.25x, and limit 1 to 8. And in this case, we have been calculating on this as it is, and found this value, and finding this value, and this value, and finding 1.36. Okay, so 1.36 we have been found here. If we go to the books of Hitler book, and we can see the same math is given here. The 8 feet and 4 keep, and x1 is taken here, and x2 is taken here. So 10 feet is here. For virtual moment, it is not. Firstly, we have to calculate the real m is given here. So in this case, we have been finding m2, and m1 40 into x and x2. So real, we have been found m1 minus x2, and minus 40 into plus 2xy. We have been founding here minus 40 into 2xy, and m2 we have been found 25, and the 25. For the virtual, we have been seen from Hitler book that they are calculating, and m1 equal to 1x. So you can see here m1 equal to minus x means 1x, and m2 equal to 1.25 minus 2x. So we have been found here. So all these things are the all are the same as it is Hitler's books. And lastly they have been taken the they have found the final result 1.36. We have been I also found 1.36 inch. So all are same. Okay, let's see another example is determine the mm, tangential rotation at point C of the frame is shown figure. Taken EI and I is given here. So this is the frame. So the real frame is given here. The 5 kip is load is given here, and 60 is degree is given here, and AI is given here. So we are divided this 2 here. So this we are taking x1 and this is to the x1, but it is the horizontal load, but we need to this corrected this for inclined load. So as we know this is the 60, this is the 60. So what will be value of this load? Okay, I'm just erasing again. As we know this is the 60. So if we calculating here, so we just increase here. This is will be 60 as it is 60, and if we the getting the 90 degree, it will be 90 minus 60, it will be 30. So that's why it is a 30. So as the load will be this what we will say as the theta. So that's why it will be cos theta, and another one will be sin theta. Okay, now we are calculating here. We can see here the minus 5 sin 30 is going this word. That's why another load we are taking. If we taking the moment is here, this portion, then it will be minus sin 30 into 3 as the length is given here 3, which is 7.5 kilometer, and this is the 5, and that's why the balance purpose it will be also 5, and it will be also equilibrium condition, it will be 5, and it will be 5 into sin theta into 7.5. Okay, so the final diagram we can see 5 sin theta, and x1 is here, and 7.5 in 5 is here, and x2 is here. Okay, so we are taking the moment is x1 is here, so we are just taking moment is here, we're just cutting here. So we are taking here, we're just cutting here. So m1 plus m, 5 plus sin theta, 5 plus sin theta into x. This is the distance of air. Yes, so m1 will be 1.25 into x. Okay, and we are seeing here x2 is here. So in this case x2 is also here, x2. So we are cutting here, and this is the cutting here. M2 equal to 7.5. 7.5 is the moment is given here, as we have been seen how to moment transfer 5 into 5 sin 30 into 3. In this case 7.5 is applied and found M2. So these two value we have been found from real structure M1 and M2. So let's see the virtual frame. So as we have been seeing the rotation at point C. So this is the point of C we have been seeing. That's why 1 kip per meter we have been applied load is here. Okay. So 1 kip per load is applied in this direction, that will be this direction it will be, and it will also this direction. Okay, so now we are separating here. This portion is x1, we are taking as it is, we have been taking the x1 is here and x2 is here. So in the same way we are taking x1 is here and x2. So x1 we have been cutting here, so we are cutting here, and x1 equal to m into 1. How will get 1 is the 1 kN per meter. And for x2 the same as it is, we are getting here, if we cutting here, then we are taking the moment is m2 equal to minus 1. So these are the 4 equations. Number 1 block letter m1, and m2 is a block letter 2, and small m1 and small m2. Now we are just putting all this equation here. I'm just summarizing. I'm just taking a small short, because if we write this, and the equation will be formed like this. That's why I'm just taking the EI is common. EI is common, and M1 bigger M1 plus bigger m1 into small m1. So bigger m1 we have been found minus 2.1 and small m1 into minus 1. So let's see bigger m1 is minus 2.x1 and small m1 is minus 1. So we just putting this value dx, the condition, the length will be 1 to 3. Why? Because this is this length. How much? What is the length? This length is 2. Okay. And another one which is 0 to 2, which is 7.5 to minus 1. The which is this is the called bigger one and this is the small one. So bigger one, bigger m1 with 7.5 we have been found. This is the 2 meter. This is 7.5 and another is minus 1. So that's why 7.5 into minus 1. And why 0 to 2 limit? Because the length is given is only 2 meter. This is the 2 meter particle. Okay, so now we are calculating as it is and finding this value which is 26 EI, which is from 0.0087 radian. So it is also taken from Hitler book. This is the determine the tangential rotation at point C, shown figure we have been seeing here. As this is the real load, as we have been seeing. The solution is taken here. The real, this is the virtual load and this is the real load. So real load case we have been seeing m1 minus 2.5 found. So if you go to the real, he say m1 minus 2.1 and m2 minus 7.5. So m2 minus 7.5. And the virtual as it is m theta 1 equal to minus 1 and m theta equal to 1. So as we have been found 1 and minus 1. And after the calculation we have been found 0.00875. So we have been also found 0.0087. So these are the our answer. So I think you can understand all things. If you have any question then let me know. I hope that you can understand. Thank you everyone.